Hello dear students, let us move on to the next part of module 1, that is dihydric alcohols and ethers. In today's part 1, we will be discussing an introduction to dihydric alcohols, oxidative cleavage reactions of dihydric alcohols, and pinacol-pinaclone rearrangement. Dihydric alcohols, as we have already seen, are compounds containing 2-hydroxy or OH group in the molecule. A common example is ethylene glycol, CH2OH, CH2OH. Its IUPAC name is ethane 1,2-diol. It is an industrially very important compound as it is used in the preparation of several important organic compounds like dioxane, nitroglycol, glycol stearate, etc. Moreover, it finds application in a wide range of areas. Like in laboratory, it is used as a solvent for cleaning food and vegetables. In semiconductors, medical field, it is used in welding and in PCBs, printed circuit boards. First, preparation of ethylene glycol. We are only studying one method, that is preparation from ethylene by oxidation. Oxidation of ethylene or ethane by using dilute alkaline potassium permanganate solution yields ethylene glycol. And this dilute alkaline KMnO4 solution is known as Bayer's reagent. So in the presence of Bayer's reagent, nascent oxygen and water molecule adds on to the double bond to give ethylene glycol. Coming to the chemical properties, here also we are studying only one reaction, that is oxidative cleavage of ethylene glycol using HiO4, that is periodic acid, or CH3COO4 times Pb, which is lead tetraacetate. So, when ethylene glycol is oxidized with periodic acid or with lead tetraacetate, oxidative cleavage, that means cleavage of carbon-carbon bond, occurs with the oxidation of the two ends. So this fragment of CH2OH is oxidized to corresponding aldehyde, which is formaldehyde, and this portion is also oxidized to formaldehyde. So we get two molecules of formaldehyde, HiO3, which is iodic acid, and water. So this reaction is useful in elucidating the structure of compounds that contain OH group on adjacent carbon atom. Therefore, we can also use to locate the position of adjacent carbon atom carrying OH group. Another advantage is this: number of periodic acid molecules consumed during the reaction will give the number of adjacent OH group. Now, coming to another reaction of ethylene glycol, which is a named reaction known as pinacol-pinaclone rearrangement. Before studying the rearrangement, let us see what a pinacol and pinaclone is. A pinacol is a diol, just like ethylene glycol, that has two OH group on the vicinal carbon atoms. Pinacols are otherwise known as 1,2-glycol. As already said, ethylene glycol is another example. If we replace all these hydrogens with methyl group, we will get tetramethyl ethylene glycol. That is also a pinacol. Now, the oxidative products, that is, the aldehydes or ketones formed by the oxidation of a pinacol is known as pinacolone. Let us see here. Here, ethylene glycol on oxidation, one of the CH2OH group is oxidized to CH double bond O, which is aldehyde group. Therefore, this is known as a pinacolone. So coming back to pinacol-pinacolone rearrangement, that is pinacols on treating with hot dilute sulfuric acid undergoes rearrangement and dehydration to form a monoketone known as pinacolone. And this acid catalyzed rearrangement of pinacol to pinacolone is known as pinacol-pinacolone rearrangement, and it was discovered for the first time by William Rudolph Fittig in 1860. Let us go through the mechanism. First step is the protonation of any one of the OH group in the presence of an acid. The lone pair of oxygen atom attacks the H plus ion, whereby we get an oxonium ion, that is COH2 plus ion. Now this is a living group, good living group. So in step 2, which is the formation of carbocation, this living group leaves as water molecule, resulting in the formation of a carbocation. Now, this carbocation is unstable, so the methyl group migrates from one carbon to the second carbon along with its electron. That is, CH3 minus migrates from this carbon to this carbon, and we will get a second carbocation with a positive charge on this carbon. This step is called 1,2-alkyl shift. Now, in the third step is the deprotonation. That is, in order to stabilize this carbocation, this electron pair, lone pair, is donated to between carbon and oxygen, thereby attaining a double bond. Oxygen attains a positive charge. In order to alleviate this positive charge, H leaves as H plus, and we will get the pinacolone as a result. Now, why study this pinacol-pinacolone rearrangement? Because pinacolone is an industrially important compound. It finds application in drug industry. It is used to prepare a cyanoguanidine drug called pinacetyl. It is also used in the synthesis of stiripentol, which is used in the treatment of epilepsy. It is used as fungicides, pesticides, and herbicides. So that is all in the case of ethylene glycol. Until we meet again with the part 2 of this presentation. Thank you and bye.